Greetings, student. This is a recording of one of Garnett's online math lesson classes. You have been granted access to watch this video because you're a paying student, and I have seen it fit to provide this recording to you. However, it is important that you know you're not allowed to share this video with persons outside the lessons. This policy is so that my services are kept only to my students. Thank you, and I do hope you enjoy and learn from this video.
All right, so we more or less left off here last class, looking at the calculating area. Well, determining the area of irregular, right? These aren't regular polygons, right? These aren't regular polygons that we're accustomed to having where we know a formula. These irregular polygons are irregular shapes. On the graph paper, we would need to count squares, right, to get the area. Now, moving off forward from this, we're still on the frequency polygon, but I'm going to mention this again. The frequency polygon is mostly used for group data. So far, we've looked at the line graph, the bar graph, and the histogram, the line graph, and now the frequency polygon. And one thing you'll notice is that the histogram is for the group data, bar graph is for ungroup data. Usually that's what you'll see. And for the line graph is for ungroup data most cases. And the frequency polygon usually for ungroup data, for group data, sorry, right? And this is one of the reasons why, because with group data, usually with group data to plot a frequency polygon, which again is just a line graph with two boundary points, right? From an extra boundary point at the end and an extra boundary point at the beginning. Now, to plot a frequency polygon with group data, meaning you have your class intervals and you have your frequency, to plot that, you would need to first get the class midpoint. We went through class intervals and we went through getting the class midpoint, not last week, but the week before that. So you know how to get the class midpoint, right? So looking at so look, this is our, again, group data. Now imagine this is a dash. It's an underscore, but it should be a dash. I think it was a computer issue. I believe it's a computer issue. Just imagine that was one. Good. So imagine those are dashes. So this is our grouped data, again, grouped into classes, and this is a midpoint for each corresponding group, right? You know how to get the midpoint. This shouldn't be now you have your frequency, right? We have our frequency for each class, and this is what you would plot, right? This is the information you would use to plot your frequency polygon, right? The class midpoint for each of your respective class and the corresponding frequency, right? Again, you need to pick a suitable scale that includes all your observation. And of course, when you reach to your y-axis, you need to pick a suitable scale that includes all of your frequency, right? Lowest to highest. Now, I showed you guys the technique that persons use sometimes. It's to take the highest frequency. Yikes, it's a rough number. Sometimes you could, there are cases where you can take the highest frequency and divide it by a certain graduation that you want to use. Let's say two boxes. You want to use every 2 boxes, whatever the case might be. Let me stop saying boxes and actually use the unit of measurement. It's 0.4 centimeters. So let's first look at our horizontal axis. That'll be our class midpoint. And again, your horizontal axis is usually your observation axis. So you put your control variable there, and your frequency usually goes on your y-axis. Same thing I've been saying last week. Good. So the scale we're using here is every 5, which is 1 centimeter. So every centimeter will be 2.5, right? Now, while we were doing, one thing we picked up on when we were looking at class intervals was that your class midpoint, because your class size is always the same, never more or less your class size remains the same throughout each class interval and the class rank, and we can identify the class rank. When we were doing the exercise on class intervals, we recognized that there's actually a pattern within the class midpoint, right? There's actually a pattern here. So we can going from 2.5 to 6.5 to 10.5, then to 40.5. What is the pattern here within our class midpoint? Anyone?
Sorry, going up by 4?
Add in 4, right? So you just plus 4, plus 4, plus 4. So you should be able to know, to guess what the other midpoint would be, right? Plus 4, 14.5 plus 4, that'll give you it. Because remember, again, we need those 2 extra boundary points to create our frequency polygon, right? So that's how you would get it using your groups, right? Your class intervals. You need to pick up on the pattern. You know what will be the next class midpoint if there was a next class, right? So keep an eye on those patterns. All of your class midpoints will have that. Will have a pattern, not necessarily plus 4. So we're finished with, we'll get back to that just now. But we finished plotting our midpoints on our horizontal axis. Again, the scalar is every 1 centimeter is 2.5. Right? Now, with regards to our vertical axis, just gonna count in 5s every 3, right? And every 3 will be 0.6 centimeters. Again, 5 boxes is 1 centimeter. Every small box is 0.2 centimeters, right? So every 3 would be 0.6 centimeters because it's every 3 boxes. So our scale that we're working with, right, just has the y-axis scale, but every 5 is 2.5 or 4. So four units. If you don't actually, just to go ahead and plot our points. We went through all the plot points before. These are simple points to plot and connect them each using our lines. Connect them each with the line. I went through the process of plotting the values, going ahead and figuring out where these values would land. Well, 35 and 40 is easy. For 43, that one you have to scuffle between 40 and 45. Yeah, that's the only one that's not directly on one of these graduations. Good. So we have our 4 points for each class midpoint. Now, the next thing to do would be to, right? Next thing to do would be to get our boundary, right? Usually it's 0. Our lowest, it's usually 0, and we have 18.5 because we know what the next midpoint would be, right? Now, right. So we have our points at these 2, I want to call them boundary points, and that would close off to give us our frequency polygon, right? Now, one thing you'll notice one thing you need to know about the frequency polygon, like I said, it's usually used for group data, and your histogram is usually also used for group data. So what or something you might see, you might often see is a superimposed, a superimposed graph with your histogram and your frequency polygon. Or you might see a superimposed graph with your line graph and your bar graph, right? Now, again, remember frequency polygon group data most of the times, same with the histogram. So looking back at it, same points, nothing has changed, but now we're going to superimpose. Now we're going to superimpose the histogram and the frequency data. To superimpose your data set, to superimpose the histogram on the frequency polygon, what you need to do is you need to recognize that your midpoint, right, with your graduations are actually in the middle of your each bar, right? So taking that the middle, this is the middle, these graduations are each in the middle of your bar. So it's somewhere here, this one would stop. The histogram would come like this. Right? The histogram. Again, the midpoint plot, the graduation for the midpoint is always going to be in the middle of the bar, right? Because this is where you plot your point, right? Now, your histogram bar, when you're superimposing your frequency polygon line graph on your histogram, when you're superimposing them, of course, plot your line graph or your frequency polygon first, and then for your midpoint, just ensure that your midpoint is in the center of each bar. Now, that will, of course, mean that the width of your bar, at least from, let's take this point, for instance, 14.5, it will be halfway between 14 and 10.5, and halfway between this bar. It will start halfway between 10.5 and 14.5, and halfway between 14.5 and 18.5. That's where the bar will go, right? It's only like that, then you'll get each. Yeah, it's only like that, then you'll get each of your bars going exactly in the middle. These graduations going exactly in the middle of the bar, right? Again, let's take one of these ones, for instance, 60.5. This bar will begin halfway between 2.5, the graduation before, halfway between 60.5 and the graduation before, and halfway between the next graduation and the 16.5, which is 10.5. So these halfway marks will mark where each of your bar will go. Okay, I missed it by a bit. I missed it by a bit. But so, and you can, I don't think you guys will have a problem identifying where the halfway mark is, right? So these things are a bit off the line, but it's 1, 2, 3, 4, 5. Because remember, using 1 centimeter graduations. So 1, 2, 3, 4, 5. Halfway would be right, split in the box, split in this box in the middle, the third box, right? And you just follow that. Good. Now, once you have each of the histogram bars, it's important for you to label them with the class that they belong to, right? So this one, of course, the 2.5 is the midpoint, and the bar here, we label it with the class interval. So 1 to 4, 5 to 8, 9 to 7, and 13 to 16. Now this does have a bar because, again, that one was just there for us to reference it as our endpoint, right? Our endpoint for the frequency polygon, right? So that is how you superimpose a histogram onto a frequency polygon. It's quite similar when you're doing it with a bar graph. It's actually the exact same thing, but again, group data is for frequency polygons. Well, yeah, group data is for frequency polygons and histograms. while your on-group data is for your line graph, mostly for your line graph and your bar graphs. Now, this is to use a line graph or when you should use the frequency polygon. So use them either or. You could use either or when you're illustrating upward or downward trends. You go to your line graphs, right? You want to show how your data is fluctuating with time or against some observation. It could be time, it could be temperature, could be pressure, whatever the case might be. If you want to look at how your data is fluctuating against a given observation, use your line graph or your frequency polygon or frequency distribution. And if your control variable, if time is your control variable observation, you definitely want to use a line graph or frequency polygon. Do not use a bar graph if time is your observation. Do not use a bar graph. Go straight ahead and use your line graphs. Last statistical diagram. I think this is this is usually a favorite, people go to. Bar graph and pie charts is the one you see a lot, right? I remember when to use your frequency distribution or polygon and your line graphs. So for the pie chart, no, all of us have seen a pie chart before, more or less constructed one. It's a circular diagram, or you can think of it as a pizza. Best explanation of a pie chart is to think of it as a pizza. So the circle is divided, or the pizza is divided into sectors, or what we call pizza slices. And I've went through how circles are divided, what sectors are, remember, bounded by 2 radii and curve. And more or less you guys explained that when we are going through. The circle is divided into sectors of varying angles and areas. So the area for each sector will vary depending, of course, on the data and the frequency. So each sector is usually shaded in a different bright color. This is one of the, it should be, right? With your bar graph, even with the bar graphs and with your pie chart, you usually use a color differentiation to differentiate between each pizza slice, right? It's boring to just have it without it. Typically, you would have it colored, right? Some color pattern within there. Now, the advantage with a pie chart is that it displays relative proportions of multiple classes of data. It shows you how much of something or how much slices of the pie each class or each observation has, right? Within relative to each other, right? Who has more frequency relative to another observation, right? And it's one of the most visually simplest graphs to interpret, right? The pie chart is one of the easiest graphs to interpret. Like for gender, okay, there's more males than females. You can see that easily by looking at a pie chart. So that's one of the major advantages, 2 major advantages of the pie chart. It's very easy. I think it's one of the simplest graphs to interpret. And it shows you that distribution, relative proportional distribution of data. If you want to look at distribution, your frequency polygon is better suited for that. Good. So we're going to look at an example of plotting a pie chart, because again, you need to know how to plot these things, even though a computer will more than likely you'll be doing with a computer. So let's plot a pie chart for the data shown below, which shows the number of students who achieved grade 1, grade 1s, right? Only grade 1s we're dealing with for the following subjects. So for maths, we have, so subject, and again, this is our observation column. Please try and do this. Identifying all of statistics, you will have an observation and a frequency, right? At least at this level. We'll only be looking at observations and a frequency for each observation. So it's best to identify what is your observation, usually your first column, and the second column is usually your frequency. So this is our frequency, the number of times a specific observation occurs. Good, right? And these values don't just mean frequency or the number of students with ones, right? So maths 17 students got grade 1 for maths, English 25, physics 10, chemistry 15, POB gross, POB 23. So right away
How dare you?
right away you can see that English has the most, so it will have more you can already, at least you should be visualizing that English will have the biggest slice of the pie, right? The biggest slice of the pie chart. Good. So how would you go ahead determining the slice of each pie? You would go ahead and use this formula. Now the first step would be to calculate the total frequency. Now keep in mind that, okay, I don't want to confuse you guys. So let's just calculate the total frequency, and that in this case is the total number of students with grade 1s, pure grade 1s, all the grade 1s, the students with grade 1s. I don't want to say it's not necessarily number of students with grade 1s, because one student could have gotten grade 1 for each one of these. So there is that, right? But that doesn't mean this is not the total frequency. It's just that it might not exactly be the total number of students, right? So got to be careful with that. But this is still our total frequency, and that's what you need to calculate, the total frequency. So let's sum up and find the total frequency by adding 17, 25, 10, 15, and 23. That's your first step in plotting your pie chart. You need to know what's the total, right? And in this case, that's 90. So 90 is our total frequency. Next step is to calculate the relative sectors, sector angle, underline this. Next step is to get your sector angles, right, for each of this sector. So first is total frequency. Next is your sector angles, right? So each subject will have a sector angle, and that's what we use to slice and dice our circle, right? The angles is what we'll use, the sector angles. So we got to calculate the sector angle for each subject, right? What sector that this sector of each subject basically. So the sector angle is equal to the frequency divided by the total frequency multiplied by 360 degrees. Now the reason why you're using 360 is because the circle is 360 degrees, right? That is the total amount of angle, the total angle around the circle, as the entire pizza is 360 degrees. And each of our subject is actually a fraction of that circle, right? Because at the end of the day, each one of them will fit within that pie chart, right? So each one of them is a slice of that. So the formula here is the sector angle is equal to the frequency divided by the total frequency multiplied by 360. The frequency of each subject, right? So the first for maths, it is as simple as, so for maths, the sector angle is 17. Again, the frequency for maths is 17. Or the number of students with 1, so maths is 17, divided by the total frequency, which we calculated earlier as 90, multiplied by 360 degrees, we get 78 degrees, right? We go ahead and do the same thing for English, then for physics, and for chemistry, then for whatever this is. So English, it's 25 over 90, multiplied by 360, 100 degrees. Physics, it's 10 over 90, multiplied by 360. Again, these values are coming straight from our frequency for each observation, right? So we have POB right till at the bottom. We are squeezing in. I don't know who is right POB, but we have the sector angle for each. Now what you'll notice, what should always happen is that when you total all these angles, all these sector angles that you calculated for each, once you finished calculating each sector angle, the total, this total should always be equal to 360 degrees. If it's not, then you did something wrong. Go ahead and check back your calculations. It should always be equal to 360 degrees, right? 92 plus this. We have the sector angle for each of our observations. Yikes. We can go ahead and plot our pie chart. Now the pie chart is a circle, so you need to go ahead and take your compass. You all know what a compass is, and draw a circle, right? Now sometimes this is drawn for you on the paper. In maths, when you're doing when they give you the pie chart to actually plot in the exam, yes, that's been done before. More or less, there's a good chance that you might have to plot one of these graphs, right, by hand. So for the pie chart, usually the circles are already drawn and it already draw a line for you. But if that's not the case, draw a circle. Don't lose the center where you place your compass. That's the center. So ensure you mark that off first, right? I didn't do that. I put the circle first, but you should have already marked the center first and then draw the circle around that. Place it, anchor, and draw the circle around that. And then draw a straight line going from your center to the circumference. And you, of course, know this is called a radius, right? So you draw a radius for the circle. Now you go ahead and start measuring these angles, right? Now we're going the same order. It's in our observation. So right ahead, let's go ahead and measure out the angles using a protractor, right? That is, we would use our protractor to measure the angles. For those of you who know how to do that, this should be simple, right? What you would do is measure, have your protractor line up. So how the app would have shown you guys this a bit better. So your protractor is that semicircle looking thing with a line going through the middle and your graduations. I know a sketch look almost look like a protractor. Yeah. Good. So you would have these graduations going around, and you would use this to measure your angle. So here you see, yeah, right. So you saw what I did. Yikes. You saw what I did with the protractor. I more or less placed the center of the protractor in the middle, or that's where our center of our circle is, and then line the protractor up with this line that I first draw. So it's important for you to have the center and a line or a radius drawn already, so you can line this up and start measuring your angles. Now here will be 0, and then you have 20, 30, 50, 60. Now I know this is clearly wrong. 60 is still yeah. I skipped 40. I can't count. But you'll start here will be 0. Once you line that up here, it will be 0, and then you go all the way up. And this is about 68, and you'll be able to get 68. You'll see 60, and then your smaller graduation. You've used a ruler before, you know that those smaller units in the middle, those would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Then you have your 70. So that would give you your 8, and you'll be able to get 68. So you would do that, you keep repeating that, right? Get your 68. Of course, you ensure you put in that's 68, so you know that, remember that's the 68 angle. And then you go ahead again, line your protractor up. Let's use a protractor to measure out all these angles. Again, they should total 360. And for each angle, you know, each angle is a subject, right? 68 belongs to math. You can use a nice color for each, right? Remember, use your colors to differentiate between them, or you can label them, but that's no fun. So yellow is.
Sir, when you went to the exam, I'll walk with crayon.
No, you will have to label them. No, you would have to label them. That's boring. No, I don't like so. If you, I mean, if the examiners see you color your stuff, I don't think that's a problem. But once you identify what each, you could instead, anyway, let me don't get into that, but you could label them, right? Actually write in maths. Well, that's what you will have to do here in that case. Write mathematics here. And then English. So on and so on. Right? Did by hand, and this is just an example of it in using Excel, right? Plotting it in Excel. Same colors, and instead you can actually get the percentage, right? How you would calculate the percentage is instead of multiplying it by 360, you can multiply it by 100%, and you'll get the percentage, right? That is a no-brainer. That should be a no-brainer, right? Instead of multiplying by 360, multiply by 100, and you get a percentage for each one of these observations. You just line up the protractor, this middle here, you line this up with the center of your circle or from wherever your angle is being measured, and then you line this up with that line, right? Yikes, we're off there by the good. So you line that up. Now you notice here is 0 and also here is 0. You would start by the line that you lined it up with. Always start from here as 0. So, right? So here is our 0 mark, right? From where we're measuring, we might be starting here from here as 0. Now you notice on our protractor, it has an inner, we have an inside grade graduation and inside measurement. We also have an outside measurement. That's because from the outside, you're going in this direction as 0, and in the inside, you're going here as 0. You use whichever one depending on where you're measuring, where you're starting from as 0. So we're starting from here at 0. We'll always start from our line, our baseline at 0, and we're going from this side. You can't start from over here because we have a line going from there, right? Good. So here is 0, so we're using the inside, and the one we were measuring was 68 as first. So let's go straight to 68. This is again we're using the inside. So instead of 120, it's 60 for us. This is 60, then this would be 6 to 1, this would be 6 to 5. They know they have. If you used the ruler before, it's similar to that. So 60, 6 to 1, 6 to 2, 6 to 3. This line will be 65, 6 to 7, 68. Right, so here would be 68, about there. Would be 68. Nope, this would be 68. Right, you would get it better. You'd be able to do it better with without this. 68 would be there. All right, perfect. All right, 68 would be here. So just mark that off. Get rid of your protractor, and now you see that line there. You just draw a line going straight. We're not stopping at the line. We go a bit past it. Now this app is drawing a straight line for me. You won't be able to do that. You would have to take your ruler and can I rotate the ruler? Oh, I can. You have to take your ruler and actually do this, right? Please just yes, and it's a bit off. This is what you would have to do, right? Take a ruler and draw the line from there, in line with your point there, and draw it to the circumference, right? So you'd have to do that with your ruler. But I have an app that can draw a straight line for me, so I just go straight. Pause there. Wow. Behaving itself. You do the same thing again, go straight. We're going around this direction. So again, line this up to 0. Again, use this in the middle, line that up with the 0, and count again. Next was 100. This was 68 degrees. And next was 100. So 0 again, we're using the inside. This is 100. That is 100. Right? Get rid of a protractor. Draw a straight line. I get this one. And this is 100. So you go ahead and do that again from here, line it up. You get the point. Any questions, queries here? Especially for those who've never used a protractor before. I hope this is better. We will be doing this more often when we get to looking at. It's only because we're looking at the pie chart that this was brought up. But when you actually get to looking at especially those transformations, you need to be able to use a protractor, especially for rotation, right? Rotation transformations. So it will come back, and I will have to show you guys this again, right? But I'm hoping that that at least clears up, clarifies what I've been explaining before with use of the protractor. Is that clear? Measuring central tendencies, right? Now, raise your hand if you already know what central tendencies are and you looked at this before. You put your hands down now. So central tendencies, we're still on the statistics. So we're looking at measuring the central tendency value of our statistic. Now, what central tendencies are is they are what we call statistical averages. You can think of them as statistical averages. It's actually what you would use to represent your entire data. So if you're looking for one value, right? Let's say I ask you, yeah, you got all that information. Give me one thing I could put on the news in a nice statement. One value, right? Because I don't want to hear about the highest frequency is this, the frequency for this observation is that. I don't want to hear all that. I don't want to see all those numbers. I don't want to see all those graphs. Give me one value, right? Give me one value that tells me about your data set. That is a representation of what's going on in your data set. Those what your central tendencies are, right? There's one value or one central tendency that you can fall on that tells something about your data set. One single value that talks about your data set is your central tendencies. And we can also, we'll also look at next week. Going at a good pace, of course. Next week we'll look at dispersion, where values that can tell us how the data is dispersed. This tells us how our data is centralized on a specific value, right? So there are at least three statistical averages or three central tendencies that we got to be able to use. And I do recommend you use them when you're working with your own data set. You're doing your SBA, you have your data set, you got your frequencies, you have your observations. Look for these values, right? And see what you can interpret from them. And even when of course, you use your graph, right? So you have the mean, or what is called the arithmetic mean or average. You have what is called the medium or the middle, that's the middle value. More on that becomes more important when we look at measures of dispersion and central tendency. But the middle value can tell us something else. And then we have what is the most popular value. You can already tell the most popular is the one with the highest frequency, right? The data says the highest frequency. We will go through how to calculate each scenario when we have group data, on-group data, because it's a different formula for both. And mean, mode, and medium, you got to be able to calculate those three central tendencies when you're looking at group data, as well as looking at on-group data. It's not the same thing, right? Let me tell you that right now. It's not the same thing when you're calculating these central tendency values for both data. Now, how we will go through this is in stages. We look at raw data because you can actually get the mean, mode, and medium from looking from your raw data directly, right? That's before you put it in the frequency table. You can get the central tendencies, or you can get them from your frequency table. That's if it's grouped or ungrouped, you can get it from your table itself. You can get them from your graphs, but really, I won't be showing you that. Yeah, I won't really show you that table, right? You can get them from the table, right? So let's start off with the mean, and the statisticians, the symbol for mean, at least the statisticians is used, is X. Oh my gosh, I actually forgot what this symbol means. It means mean, it means average, but oh wow, I'm ashamed. Okay, I forgot what it is called. We call it a stroke above the X. I forgot what it's called. It's not coming to me. All right. Okay, we'll let it go. So you have an X with a dash on top, right? And there's an actual name for it. I forgot. So the mean for a given set of data, I will remember by next class, don't worry. So the mean for a given set of data is commonly referred to as average, right? We know this, average is the mean, right? That's all concerning the definition of the mean. What the definitions are important. This is what's really more important is calculating it, right? Now, again, I'll show you how to get it from raw data, then on group data, then we look at group data plus. So to calculate the mean from raw data, please note that this is calculating mean from raw data and not calculating the mean from anything else, right? This is from raw data. So we go from raw data, then we'll calculate mean from so on and so forth, like I've explained before. So this is a formula for calculating mean from raw data. Now, the only reason why I've actually placed this formula in front like this is because I want you to, is because I more or less want you to understand the symbols, right? The symbols. So this is called epsilon, a capital epsilon. This is called epsilon, and it means the sum of, right? It means the sum of. So whenever you see this, because you mathematicians like to use this symbol in formulas, it means the sum of, right? So epsilon x, which means the value of an observation or variable. Notice it's the value of an observation, not the frequency. So be careful. Look at the observation and not the frequency. Observation and frequency is not the same thing, right? Observation is a specific, what you're looking at as your first column. Frequency is how many times an observation occurs. It's not the same thing. Don't get mixed up, right? Don't get mixed up. So the sum of the observation divided by the total number of observations, right? Total frequency. Again, n is total frequency, right? And that's the total number of observations. No, it's not total frequency, it's total number of observations. Don't forget I said total frequency. It's the total number of observations. It is the total frequency. I don't know why I keep that. Good. So right here you have an example. I just put everything up. So this is our raw data. Remember, our raw data is just a list of numbers. We haven't put it on a graph. We put it on the frequency table, right? This is our what we call our raw data. Now, in the raw data are a list of observations. So 1, 3, 5, 7, 11, 12, 13, 15, 16, and 17. Now, if you want to calculate the mean of this set of data, it's again, this is the symbol for mean, x dash, can't remember the name, epsilon x divided by n. Now, epsilon x means the sum of the value of each observation. X is the observation. Epsilon x just means the sum of the values observed, or the values of each observation. Just means that you add all these numbers together, right, and divided by the total observation. So what this is just it in symbols. Again, I just want to introduce the symbols to you. N means total observation. Epsilon means the sum of. This one will pop up. Not. So remember these, right? And X is a value of an observation. Now, I'll write it out in words. So mean. So right again here, the sum would be adding all these numbers together, and the total would be counting how many numbers there are. So 1, 2, 3, 4. So the total number of observations, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 observations. So sum this up and divide it by how many numbers there are. That is our average or mean, right? Or statistical mean, right? Arithmetic mean. And that is it concerning calculating our mean from raw data. Now,